Okay, I think the red button has come. Okay. I hope I'm audible, guys.
Yes, yes.
Okay. So, first of all, good morning for people out here in India, and for everyone else, good evening. My name is Dolcy, and today it's going to be a very simple interactive session. It's nothing very heavy duty. So, we'll be walking through this transformer model. It's basically nothing but a detection model for identifying tables in PDFs. So we understand that tables is a very good way of representing information, and of course this is a very big use case and a big challenge, since lot of information can be lost when you're trying to convert a PDF into a JPEG to, run multimodal LLMs on it. So this was a very innovative solution to identify tables directly from a PDF table, from a PDF file, and kind of like structure it in a way that we can use it further for our analysis. So today it's going to be a very simple walkthrough. I'm just going to give you an overview of what table transformer does. So here is the model card from the Hugging Face library. So nothing but a table extraction system, a model which kind of extracts table, detects them. So the structure is somewhat like this, that we'll see as we move on to the code demo, that it will be able to detect the table. So you'll have to specify a few parameters so that it accurately detects these tables, and we are able to extract these tables and see if we can, run our LLM inferences on it. All right, so let's get started. Let me just share the codes. Okay. So as you can see, we are using something called Llama Index, Quadrant Clients, and all these libraries to, kind of like make our workflow. So before I get into, like, giving the depth of how we started, I'll just like give you an overview. So our idea was to use table transformers so that we can have better inferences on our tables. Now you understand that since I come from a medical background, I've seen a lot of clinical trials have these tables which are generated as part of, data collection. You even see that, these tables are generated as part of blood reports and other various tests that are conducted for medical sciences. So table understanding, if we could directly understand and, get the values from a table, wouldn't that be amazing? So this is what we're trying to do here. So we've loaded a file here, and we've kind of like image gotten its pixel map. So this is a very big parameter that goes in to the table transformer. So you need to provide a pixel map. So in order to calculate the pixel map, we have kind of like, taken the PDF and checked it page by page by page, and then we have asked the, we've written a piece of code to show us these pages. So here, if you can see 3 pages. Now, according to these images, there are no tables in this, but the document that we see, the PDF file that we have, it has a collection of documents and texts. It has a collection of text and tables and pictures and images. So here we'll see if we can directly accurately, capture those tables directly from the PDF or not. So what we did was we created a
Yeah, increase the font of the text.
just a moment. uh, I think.
You can just do Control Plus. That
Huh.
will on
Okay.
your Windows laptop. Yeah, yeah, yeah. Good. Now it's good.
Okay, fine. So you can see we're using something called quadrant client here, and we're using a quadrant vector source. So what does this quadrant client does? So as we go down in the code, you will realize that quadrant client is the main feature that we use to create a bounding box, to basically create a specification of the bounding box. So basically a quadrant on our images. So first we have, like I showed you, we converted the PDF pages into individual images, and we captured their pixel map. And this is how we are going to, per document. So right now we are working with only one document, but yes, per document there are multiple images created and they are added to this image collection. All right. And the vector store is also there to kind of track the text and the images together, so that we don't lose information at all. And this is what we have done. So we have created a vector store from those images along with their texts. Text collection is also along with it. All right. And then this is what we have done here. Multimodal vector store is what we are using. So basically, as we see, we'll be interpreting these tables as images because it makes sense, right? GPT-4 Vision and even Gemini Pro Vision have done such amazing jobs at being such great. They draw many great references and inferences from these images, so they are very capable. So we want that to convert the table into such a form that we are able to get the LLM to directly answer our questions. So that's what we are trying to do. We are combining these images with their appropriate texts so that we can get the answers directly.
No, but first thing, how does it even detect in a
Yeah.
document where is the image and where is the table, and how does it take it out?
Okay. Just a moment. I'll just go to that part of the code. All right. This is displaying. Okay, so here it is. So what happens is when we are going with every page, so if you see with every page number, we'll be like extracting the page and getting a pixel map out of every page. So this pixel map is very easy to, capture. Now, once we've captured this pixel map, we can convert it into an image using the height, width, and setting the, RGB is nothing but the color palette that we set, which is very standard across all computers. And this is what we do. And then we save these images individually with their
Yeah,
names. And
how do you decide on this width and height? Because every document might have a different width and height, right? The different images you are capturing.
yeah, so we basically utilize this function. What we do is when we
Mhm.
get this function,
Mhm.
so imagine that you have a document. So let me just show you, right?
Okay.
We have this document. I hope it's clear. For explanation purposes, I'm showing you. We have this page, okay? So
Okay.
we have gotten the pixel map of this page. Now, the pixel map itself will tell us what is the boundary of this page, because these white space will all be one single number, won't have any text whatsoever, right? So the pixel map will have a kind of like a uniformity over the edges since there is no text or information present there. So when we extract the pixel map using the get pix map for every page, we kind of like get a boundary. So this variable will have these features because of those pixel values already set, right? Computationally, white will look a single value for across documents, right? So that is what, this is how you decide. So basically we are not deciding ourselves what would be the width or the height. We are extracting the pixels and letting that pixel map itself decide what would be the width and the height.
So
So
that is
kind of
basically
like,
the width and height of the page, right?
yeah, of the page. So that will decide the size of the image. See, the point is, how do we get the LLM to, read our tables? We know so we have to understand what does our LLM do. It can read images. It can read JPEG. It can read PNG. I know it can read text also, but here we were trying to see if we can, automate kind of, because it becomes easier to just convert the PDF document into images and getting, tables out of it. So we thought we'll follow this pipeline first. So this is how we have extracted the images. I hope that is clear.
Yeah, yeah. Thank you.
Okay. All right. So you see here, these are the images that we have seen. So now we'll see how we'll use table transformers to, kind of crop the tables from these images and see if it gives us the correct answer. So we're
So, so
using,
far, so far you got text and everything else combined.
yes, yes, it's in the same vector store. So kind of like
Okay.
together, the images and the associated text are stored together and they are indexed because L, for us, we can connect the dots anywhere, right? Human beings have a different way of learning, but when it comes to large language models, you have to specify everything. So if you fail to specify things, the model will assume itself based on its training, and which can lead to hallucinations. And we'll show you how this pipeline, as we explore further, we'll see how this pipeline actually did not do well. So we are using this auto model for object detection to kind of like detect. So first what we do, sorry, I think, yeah. So we have first resize. We have defined a class which will resize those images to a standard size. Like I told, like how the question came, right? How do we decide if all these images? So yes, it can be that one page of the PDF has only images and doesn't have text at all. So it can be that the white space is much larger compared to the other pages. So the height, since we are extracting the pixel map, the height of that page might go down, so we are resizing all the images together and then we transform them. All right. I hope this point is clear. After transforming and standardizing, so this is a very typical step that you standardize these values. So these are like standard values when you can like choose these values across. So normalize. You can set these images sizes yourselves. All right, you can resize it. So here you can like kind of depending on how much do you want and how much do you see. So here we are taking it directly from the image size itself, but you can like modify these values to get larger pictures or to get much more defined pictures. And then we create a like an object for our model, and then we kind of like call this recognition v1 et al. And this table transformer. These are the models that kind of like will help us load. These are the models which will help us detect the tables. All right. And this is what it is. So after detecting the table, what should the model do? For after detecting the table, the model should create a bounding box around it. So these values are usually standard, but you can play around with this. So as we see for this particular pipeline here, these values actually worked well for most of these image for most of the PDF tables, but for one PDF table, as we'll see, in a while, it doesn't detect it properly. So we'll also show you how we tackled those. Okay, so here we are defining a function to kind of like box out those tables, and we can like rescale those boxes because now we have an image. The image now we have an image of the entire page of the document. Within that document will be the table. So in order to get like a standard table size across all images is the reason why we are rescaling these boxes after the bounding box is done. And then we kind of output them as images. So we'll be saving these uh, the tables that we are detecting using the bounding box as images. As so here we are like doing as objects, then we'll kind of like save it as images here. So if you see this detect and crop and save table, this function will open individual files, help us split the text, help us help us get pixel values as well, and help us detect tables, and then output those tables as objects. And now we can save those objects as images. So here you can see we are saving those objects as PNG images, and then we can plot those images here. So these are the functions that we have defined. So we'll first create functions for bounding boxes, and we'll then create functions to save those bounding boxes as objects, and then convert those objects into images. I hope this up till until here it's clear. So if you have any doubts or any questions, you can like ask me. You can unmute yourself and ask me since I can't see the chat yet. So
So where the transformer will come into picture? Is this during the training time?
yeah, so this is what the transformer will do. So basically, you have to define a few parameters for the transformer to work. So what we did was we defined. So this is we defined these parameters. So if you see here, we've given the box size. We have already declared the pixel map. So these are some of the parameters that have been there. So once we do these, once we have defined functions to calculate these parameters, we can run the model on these. So here I've already initialized. So here, this is the model that will do the table transformer image processing. So this is the endpoint, the Microsoft table transformer detection endpoint. All right. And this is the structure recognition endpoint for the same thing.
So
So,
on what basis you decided those parameters?
so here, like I showed you, we decided, we kind of automated that process in such a way that the image itself will decide what the size would be. Okay. So we don't know now what kind of table, what kind of document we'll get. So
Yeah,
we are trying.
how did you automate? That is what I'm trying to understand.
Yeah. So we basically so like how I showed you here, we individually check the pixel map for each image. For we converted, got this pixel
That is
map
for
from,
whole page,
yeah, for the whole page. From
right?
those after getting those pixel maps, it was easier for us to convert that page into an image.
Okay.
Okay. Once we have given the width, height, and the samples, we can convert it into image. And then we saved it as images. So individual pages along with their information was saved as images. So here it's saving as images. And then when I was showing you like a little before, we here we have kind of like resized, transformed those images in a standard format. So here we are like calling functions to standardize the size of the images so that we can process all of them together and don't have to manually change the width and height for everything, because the bounding box dimensions would change, right? If the image pixel if the image height and width are
Yeah.
altered. So that is what we are trying to do here. So this is how we automated it. All right. And this is the function for the bounding box creation and the rescaling and converting it to objects, and finally saving those objects as images. So if you see here, this is what we have like this is what, see, the model is called here, and the pixel values that we had was one of the was one of the hyperparameters that we like one of the parameters that we passed through the model. I hope until here it's clear.
Yeah, kind of. Still didn't get that automation part. Yeah, probably. I can understand.
So, see, you have to understand the automation part is still hard coded here. See,
Okay, that is.
we're still hard coding it, some most of it, right? Because we were trying to see if this file would work or not, if this method would work or not. So if we go down and see, now that we have success, so we have initiated the vector store, created a vector store so that it is easier for us to retrieve. So the LLM understands vector embeddings much easier, right? Because computational models. So
No,
we kind
basically, when you say automation, right, in general, so there will be some loss function and it will try to kind of improvise.
no,
I was coming from in that angle. Okay.
uh,
So I didn't
okay.
see that. That's the reason when you say automation, so it is
So
more of a hard coding based on the paper or something, right? There is
yeah, yeah, yeah.
nothing like,
So
there is nothing.
automation in the sense, not like training the model per se, but automation in the sense that it automatically detects the pixel map and kind of like creates the images out of it and decides what the bounding box and all of these parameters would be. So that is what something that right now, of course, we have hard coded this part right now. But if we have created those functions. So if we run them on different if we run them on different PDFs, it'll
Hmm.
run the same. It will automatically decide the boundaries of the page and then create a pixel map out of it, and then create the bounding box out of it.
So
Okay.
is this based on experimentation you have put it, or was the paper, I don't know which paper you referred or something?
No. So basically, this code was initially prepared by one of our community members. So
Okay.
this was based on experimentation alone. We were
Okay.
trying to solve
That's
this
what I was
problem.
trying to understand.
Yeah,
Yeah.
yeah. We were trying to solve this problem, and so a lot of times what happens is, generative AI has very good capabilities. Like, it is generative AI mostly targets sequence to sequence, right? If we can give any form of sequence to our LLM, it will give us the probability of the next token. And if we go to GPT-4 and Gemini models, they're pretty
Mhm.
good at that. They're
Yeah.
very good at that, right? So they've been trained on millions of tokens and billions of tokens, I would say. And so we want to leverage that functionality also. But how do we do that?
Yeah.
How we need to find a way. So instead of like directly approaching it, that directly cutting out physically or manually doing something, why don't we write it in code? We know that our latest large language multimodal LLMs are very good with understanding JPEG, and it's very easy to convert a PDF into JPEG. So how can we design a workflow where our PDFs, you give us your PDFs, and we'll automatically detect the tables in it, and then you can ask questions to those tables. That is what we were trying to approach. So if
Okay.
you see, after running all those running all those functions that we have defined, now we've plotted two images. There are three tables in this image, and there are two tables in this image. All right. If we run the crop table function, we can clearly see that in the first image, it has accurately detected three. And in the second image, it has accurately detected two tables. Okay. See, this is the first table, the second, the
Right.
third, and this is the fourth and the fifth. Now, as we go down further, we'll be looking at these three tables. So how do we do that? We have
If
plotted
there's
those.
an image in that other than the table, let's say you have actual image, some other image, how do you identify that is between a table and a normal image? Some picture kind of stuff.
Okay. I think that the thing is, the image, if there is a random photograph or any meaningful photograph for
Charts. Let's assume you have a chart,
yeah,
right?
of a chart. So the
Yeah.
chart, you have to understand that the pixel map of the chart would be different from a pixel map of a table.
Yeah. Perfect. Yeah.
Yeah. So table transformers are trained on
Okay.
many tables to kind of like so you have to understand that table will anyway be a square or a rectangle, right?
Yeah.
It won't be a circle. You won't have a circle in a circle table.
Okay. Basically, table transformer takes care of that.
Yeah, table transformer is, so that is the reason why we introduced this rather than directly converting the PDF into image.
Okay.
We could have done that also. It would have saved us so many functions, right? But instead of directly doing that, we kind of have a guardrail in between, that we trust the table transformer. It has been trained to do this job alone.
Got it. Got
So why don't we? So basically, the whole point is that we leverage the functionality of whatever is existing with us. How so? We want to use the best of what we have and solve our problems. So table transformers is what we have the best to kind of like automatically detect. Of course, there's a lot of we had to work out the parameters a little bit, and come up with a workflow. But that is the case for every use case, right? So here we'll kind of like now moving forward, we'll look at this page alone. So now we have like detected one table. We have taken one table.
Also, one thing. So,
Yeah.
I mean, just want to know. I mean, if table transform also is very good at bordered and borderless tables, So there are two type of tables, right?
Huh.
So
So I'll show you. So right now, if you see, this is a border. These are all border tables. You see, they have demarcations of the columns.
the rows columns are not there. Okay.
Yeah, but see, but like it's not clear from here. But let me try to. So if you see this, these demarcations are there,
Right.
but individual demarcations are given only by spaces.
Yes. Yes, yes. So
All
if
right.
there overlap. we don't know how the model might work or
So
something.
we'll see. We'll see. So basically, when we tried, now we thought, okay, wow, we've cracked it. We finally cracked it. We reached this point. But you realize the top line is cut.
Right.
So this is a problem that we'll face. Now, when we ran the when we now we've gotten the table. Suppose, let's say we've gotten this table, and we now are going to send it to our GPT-4 vision preview, and we want to see if what is the comparison between llama 1 and llama 2 on the squad and quark data sets. All right. So our question is, compare llama 2 with llama 1. Now, if you see this answer, the table you have provided seem to be comparing the performances. So it does a pretty good job. It is able to correctly detect that on the squad benchmark, llama 2 generally outperforms llama 1, even in all shots, right? And it is giving all amazing answers, and it is able to effectively uh, give us the column names and the sections. The other tables are there so there were three tables that we had extracted. I have shown one over here, but the other two tables here. So this is these are all nothing but model comparisons on different data sets. So here the natural questions data set and the trivia questions data set is explored. Here squad EM and quark is used, and here some other model like other configuration model names, and those functioning are used on benchmarks basically. So for this squad data set and quark data set, llama 1 and llama 2 are compared, and if we can see in the table itself, llama 2, of course, it is doing much better functionality. It is like a more evolved or a refined version of llama 1. So we can say that the LLM does a pretty good job in understanding this table. But now you think that, wow, we have solved this problem. It's amazing. It's doing things. But we wanted to test it further. We wanted to see if it is actually doing something well, or is it just giving us a superficial answer. Because you see, this table has a lot of values, but in this answer, nowhere it has compared those values. It could have told us, right, that the range of llama 1's performance range is this, or llama 2's performance range is this. We generally do that, right, when we are comparing, when we were kids, when we were writing comparison difference between two, we'll generally start with the basic things, right? What are the basic facts which are different between the two objects in question? Then we'll write more features and things like that. But here, the basic fact of those numbers, that how did it actually perform, the quantification of those number, the quantification of that comparison was not shown. So it did give us the answers of the token size, sorry, the parameter sizes, but otherwise it didn't give us the numbers at all, but it gave us a correct answer.
One thing, so you mentioned about table structure detection also, right?
Yeah.
So did we do that when because we only did, I think, did structure. I mean, we only did the complete table, but
Okay.
the structure part, where are we extracting and giving to the llama?
I think it's somewhere here. Okay. Okay, just give me a moment. No, I'll come back to that.
Sure.
Okay. Just like make a note of it. I'll check and let you know where we're using. But anyway, moving forward with this, so like we can see that the answers that we see over here, they are pretty decent, but the numbers and the values that we want to see in a comparison, we don't see. So we wanted to further explore different what else we can do. Now, taking back to the previous, not the question before this, but just one question earlier, that whether we are doing borderless or boundaryless or non-boundaryless tables. So if you see these tables, when we are doing this method, directly doing this method, it is kind of like cropping out the column name here. It's not doing a proper job when we are trying to automatically detect these tables. So we wanted to, kind of like tackle this. We wanted to tackle this question, this part, and we also wanted to tackle why the numbers and the values, the quantifiers not being displayed in the answers. So we also checked again. We ran a complete prompt, all the image documents, and we saw that on all the tables, on all the three tables, it is giving us answers. And now if you see, it is giving us values, but these values are wrong ranges. I mean, 60.0 and 68.9 exist in the table. So if you see here, 60.0 and 68.9 is there. The model did not hallucinate these values, but the ideal range should have been 60.0 to 8.0, 80.0, because those are the highest values in the squad EM dataset for llama 1. But it is not able to accurately, capture that range here. And here also, if you see 38.9 to 65.8, so that's on the F1 dataset. So if you see on the F1 dataset, I think F1 dataset is here. F1 dataset is in this table, and if you see that, it's cut out. The top column names are cut out here. So how do we tackle these problems? How do we, understand what to do, and kind of like how can we, get more accurate values for these answers? So we came up with another pipeline. See, this is kind of like a work in progress code, and we've made headway using these table transformers. But I understand that there are certain shortcomings in this, and we are working on it. But meanwhile, the other pipeline that we came up with was the hybrid OCR pipeline. So now we have an image, and we have its associated text also. But our LLM is still not doing a good job in answering, even though we have given it everything. And ideally, GPT-4 should do well with images, right? But it is not doing that good job. So we thought that why not, with the help of LLM, we do another step of conducting OCR. So what this OCR will do, it will take that image, it will, it will get the width and sizes of that image, and kind of like have an image dimension and encode that image. So it is, we have taken those individual images of the tables and encoded them, and we are using a library called Tesseract to do our table text detection, to do an OCR on it. Now you must be thinking that why did we come up with this, and why are we doing this? Unnecessarily adding, things, and maybe we could have, kind of like modified the table transformer pipeline a little bit more. So we realized that we were tackling this problem as part of our LLM jam session. So this was one of the most popular and the easiest method that we saw would give us, like, much more better results. So we conducted the OCR on our table information. Now Tesseract did a very good job initially, but if you see, there are some values missing over here. These values are missing. Also, these values are missing. Also, the 7 billion, the 13 billion should have been higher up. The 33 billion and 65 billion were lower below. What about the llama 2 values? So these values, the job that the Tesseract did was not very accurate. So the point is that once we get the values, the text from these tables, our LLM will respond much better. So what we did,
No, basically, you are saying that the LLM inference, GPT-4 inference on table individually is not correct.
yeah,
The
it's not
OCR
about,
inference
yeah.
individually is also not correct.
Mm-hmm.
Okay, so you are going to mitigate it. So they are
Mitigate it
individually
together.
both are not correct.
Yeah. So
Okay.
we thought that, table transformers are pretty decent, but when so I'm sure that if we make modifications to the table transformer pipeline, we might get a better structure of the table. We might get the table accurately cut out. But even then, we saw that one table which was accurately cut out, it did not capture the, the long range that we see in tables. So one column, the first column can be connected to the 10th column, right? So that kind of that kind of range dependency was not accurately captured, because ultimately you have to understand that there is no object, there is no human being, or there is no physical thing present in the table, right? They're just numbers. So these GPT-4 these vision models, these multimodal LLMs are very good at understanding and detecting object in an image, but here the objects are some random numbers, right? So for the, if you look at this table and if you think of it in a computational way, how would the LLM see? LLM would see white space here individually, right? And all these texts would have one, so all these numbers would have one pixel value. So black will be one pixel value, and all this white would be one pixel value. So what would the LLM think? LLM would think that, these are nothing but blobs of black and these are whites. It won't be able to make sense because there's not much pixel information for the LLM to draw inferences on. So LLMs can, understand, right? That, okay, they capture the features and parts of images, and that's how they develop, have an understanding of, okay, this can be this object, this can be this object. But here, we're just giving the LLM a bunch of numbers as images. So of course, it did not do a good job. But here, so what we did, now that we have ran the tesseract pipeline on on our on our tables that we extracted, we saw that the tesseract did not do a good job on one way, on one go. So instead of kind of like repeating this step this way, we send this OCR file. So this OCR object, so whatever we have gotten out, this and this original image to a large language model as input. So this would be the input, this would be our context, and the prompt that we have given is that you are part of an OCR pipeline, you are an OCR engine, and we are providing you with the original image. Your task is to perform corrections on the L1 OCR that we have sent using your capabilities and give us a correct result. So we did that. We created the model. We sent the image encoded table as the L1 thing, and the original, and this is the table text that we got, and the encoded image table, that the image that we had, the table image that we got. Now this is the answer. Now you can see it does a much better job at giving us all the values, the alignment is correct, the numbering, the naming is correct, and all these answers are, I have filled the missing, and it gives us the the original image provided. So we wanted to see if this works or not, right? And we wanted to see that if it actually captures the correct value. So let's go back to the table and see if natural questions, how does the llama 1 do? So it's 16.8 to 39.9. That is the range on natural questions. So let's see if our LLM accurately tells us. So it does. So this is what we wanted to achieve, that it is able to give us all these names and numbers accurately. Now I understand that you guys might be having questions that why did we do this, why didn't we modify it. So I just want to give you guys one more thing, that this is a work in progress kind of a model, kind of a code. We were trying to kind of come up with answers, innovative answers, so that we could easily run these pipelines and get some meaningful output out of it. So of course there are two major areas of improvement here. One is optimizing the table transformer pipeline, and the other is kind of like streamlining this OCR process in a much more defined way. So I think that's about it.
So for OCR, you used any package or it's a
Yeah,
user
we use Amazon Tesseract.
or Tesla used? Okay.
Yeah, we use Tesseract. So it has been much given much in, like, validity, and it's been used by a lot of people, and it does a pretty good job. I mean,
Yeah.
it did 90% of the job, it did, right? But we were not, we don't want 90%, right? When we are working, and when we are making products which are going to eventually, be sold or will be commoditized, we
Mm-hmm.
don't want to do we don't want to give a 90% accuracy, right? If a
Right.
doctor comes and tells you that you may have this disease with 90% accuracy, you might not go to that doctor again, ever. So the question of failing, not to fail, is the only reason why we came up with this OCR pipeline. And actually, one of our contributors, you might have heard of him, Bhavesh. He was the one who suggested the OCR pipeline as well. So that's why we went with the solution. And of course, there's a lot of work to be done. But since we had a working code and we wanted to show how table transformers really do the job, and if it is working or not, and if you need to augment the current pipeline or not, so we wanted to showcase uh, this webinar.
Yeah, no, good job. So this table transformer is not open source, right? So you have to buy from. So
No,
like,
table transformer is open source only.
but you're using Microsoft this thing.
Yeah, it's from Hugging Face, no?
Oh, you used Hugging Face. Okay.
Yeah. It's no, so it's launched on Hugging Face only.
Okay.
So I had a question.
Yeah.
Since the header information was discarded, why was it done? Why was the header information discarded from the table transformer?
Header information was discarded.
It gives the header information from it gives the structure of the table. I think I've read the paper. So yeah. So
Yeah.
why was the structure of the paper of the table
So
discarded?
I think they were trying to kind of like iron out how we are running this. So the structure of the table was not integrated then, and I think probably one of the major reasons why it did not accurately, it cut out those column names as well. So yeah, there see that I checked the code for that table or detection, the structure detection thing, and I realized that we have not used that part.
Yes.
Yes,
Yes.
we've not used
Because
that part.
because this is a simple table, right? For anything more complex, I think the structure will be needed. The structure information will be needed.
Okay. Okay, so let me do this. Let me just recheck everything. So actually, the thing is, there's still a lot of work left to kind of, take take this. Let's see if we're using structure model anywhere.
I think you're not using structure.
Yeah, we're not using structure. Yeah.
Because the main reason for the paper was it was also detecting the table, but detecting the structure of the table, the headers and everything. So
Mm-hmm.
that was the main main message from the paper. Because I have read it, that is why I
Yeah,
know it.
yeah.
Yeah.
No, I totally understand. So, thank you for pointing that out. I'll introduce that, and we'll see if that improves. So maybe we might not have to do such a level of OCR. So we did a two-step OCR, right? So we might not have to do the two-step OCR, and but but anyway, even then, if we define the structure and the boundaries accurately, we saw, right. So one of the tables was accurately cut, the boundary and the structure of the table was accurately cut, and even then the GPT-4 did not do a great job. So
Yeah.
even if, so maybe we can have better detection of tables from table transformers alone, but if we want to convert it to images and directly get the LLM to draw inferences on those images, it will fail. So it will give you pretty good answers, much better answers than just decoding the PDF and then sending the PDF pages as individual documents. It will do a much better job than that.
In this case, it might not be required. Maybe, but in some cases, headers and column
Yeah,
or row headers are very important.
yeah.
Because when you see some bank documents, you need those headings. What has
Mhm.
the amount or what a
Yeah,
principal.
yeah, definitely. So that is why one of the tables we could not get the column names.
Right.
So at the moment, so I'll be honest. At the moment when we were trying to tackle it in the LLM jam, we wanted to get the answer. So the code, if we managed to get the tables out, we wanted to see if the LLM inferences are done or if we have to improve something. So yes, the change improvement areas are two. So one is the structure model that was correctly pointed out, and the other is the actually refinement of the OCR. And of course, at the end, automating all of this, that you give us the PDF and we'll give you a chatbot that you can talk to the PDFs directly. Something like that.
Thank you.
Yeah.
Apart from that, I have a question. So, I mean, so did you compare some results? I mean, only with text, OCR text, and only image and image plus text. I think you tried all three, maybe.
Yeah. Only we've done only this. So there's still a lot of work, going on this. But we wanted to kind of like get it out. So the thing is, until and unless we don't get feedback from people where we're going wrong. So one of our colleagues made this code, and when they showed it to us, it was like amazing, and we thought that okay, it's doing a good job. And then we started testing. Then we realized that the LLM is not able to actually uh, accurately capture those long ranges, and kind of intercolumn dependencies were not captured accurately. So that's when we went led, okay, all right, let's at least tackle that first, that the LLM is able to draw the inferences. And all these extra things, that getting the table out correctly, and all these things kind of become like hyperparameters that you'll have to modify them anyway. But we'll have to see if the entire workflow is working or not first, right? So the workflow should work, because if the workflow is not working, then what is the point of sending these images to OCR if that was also going to fail? So that was one of the major tackle points that we wanted to problems we wanted to tackle first. So that's how we went with this.
So, I mean, you still had to validate the results comparatively.
No, we validated these results within the tables and everything. So it's doing a pretty good job across different test cases. So we tried these test cases on 3 different tables. But the problem is that the tables, we need to take a step further. Right now we were using documentation of Llama 2. All right. So Llama 2 documentation is pretty straightforward, right? Computational documentations don't have complex charts. Our next step of validation would be to try it on very more complex tables, like clinical trial tables. So somewhat like, so basically this is just a stepping stone. This will be used for us to accurately analyze those clinical trial tables, so that we can kind of like detect adverse events. Suppose the clinical trial has a table which shows adverse events, so we want to accurately say that okay, in this study these many adverse events happened for these many people. So we want to accurately do that. So that would be our next step, to validate it on more complicated tables. But for now, for generic tables, this pipeline works pretty good. Pretty good. I mean, you would get the ranges correctly, right? I know there are certain things that we need to make changes to, but ultimately the LLM inference that we were getting was accurate. So that was the whole point.
And also, you could chain of thought with agent would have solved it. So,
I'll make a note of that.
yeah, I mean, so here you are using technique of adding the OCR image as context, so that GPT can, compare the contextual image with the table transformer embedding output, and, do the reasoning. But maybe chain of thought with agent could have also solved it.
Got that.
Yeah, possibly. See, all of these LLM architectures, folks, are like Lego pieces, right? So we see so many startups and companies trying to, do the Lego, and of course the prompt engineer. How do you structure the prompt? All of this is like a building game, and how you create that whole architecture to achieve a certain problem statement. So it's very interesting,
Yes.
and it's really down to our creativity how we connect these components and do the right kind of prompts
Yeah.
to get desirable output from GPT.
The whole reason why I wanted to showcase as well, like how me and Vivek sir were discussing this. So we have a working workflow, but we need people to show us where we're going wrong. So a lot of times what happens is, when you're looking at the code for a very long time, you kind of tend to lose perspective, right? So a third person perspective and different ideas would come from such meetups. So this was one of the major reasons why we wanted to showcase this code, so that we could get valuable input from all of you. So that we can improve. So maybe, in a week's time, we'll come back with much better working code. So now it's working. Yes, it's doing the job that we wanted to do, but still, the workflow is not efficient, I would say. Yes, I think Sunil, so you can ask questions.
Yeah, hi, Dolcy. Yeah, this is a nice, interesting approach. Now, a lot of times, scientific and numerical data. As you progress on this work, are there any plans where you might include a table which has text and numeric? Because I see that this Llama table that you compared or that you used was mainly on numeric data.
Yeah. Yeah. So that's what. So one of the reasons why we thought of OCR was also because of this, because it will accurately. So anyway, these images. This images are like kind of like, have information, textual information. So even those numbers can be converted into texts, right? So I'm sure the OCR pipeline would also work. But yeah, definitely we'll be trying it out on much more complicated tables. So if you see, there are certain tables which doesn't have text or numbers. They're just so there might be a Gantt chart, suppose. So people might be just drawing circles to mark that this is present. Attendance chart. You won't write your name or anything. You'll just draw a sign or you'll just put a tick mark, right? So we have to tackle those things, and I'm sure that a lot of so Tesseract might fail there, because Tesseract is supposed to accurately detect text, but the circles and tick marks won't be text. Right. So, of course, there's a lot of testing and trying to be done. But yes, that will be our next stage of tackling everything. Uh, yes, Rinal.
Yeah, so I just wanted to ask, what about tables that you have in terms of a CSV file? Will can this be loaded and detected by this LLM when you're loading a CSV file?
So, I think CSV file can directly be loaded as a data frame, right?
But to decipher information from that CSV file, say you have text and numerical values inside that CSV file.
Yeah, but then again,
And
it will be loaded as a data frame. So, Panda's data frame will be able
oh,
to.
okay. So you're converting into data frame and then loading it.
Yeah.
Okay. Yeah.
The whole
Makes sense.
point is that how do we do cross organization transfer and still be able to get accurate results? So not everybody will be able to provide you CSV files for their data.
Yeah.
People publish PDFs online. Research papers are published as PDFs. So
Yeah.
PDF is the standard form of information passing. Of course, images are also, but image documents, if I'm talking about, you don't pass around CSV files because it's easily editable, right? PDF, you
Yeah.
can't edit that straightforward way. So yes, this kind of like preserves the information from point A to point B, and we wanted to tackle this. So why does the person has to, go through the hassle of converting their PDF again manually into CSV? So that's what people were doing before table transformers, right? They were
Yeah.
manually converting those tables into CSV. So here, the whole point of large language modeling and the whole point of generative AI is to do to leave all these mundane tasks, these simple, trivial, non-essential tasks to the large language model, which is capable of handling it. The large language model will understand the computational data much better than us. But of course, because we are human beings, we rely on many other sources of senses, is the reason why we don't face trouble, interacting with computers, because we have vision, we have sense of smell, we have sense of touch, and then reasoning and all of these things. But computer has only numbers, by zeros and ones. So how do we manipulate those? So this was one way of kind of, like streamlining that process. And plus we have a product like KB Miner. So knowledge based miner does nothing but lets you, do an effective rack. It's an effective rack solution on any kind of document and websites. So if you want, you can you can watch out for this feature, and we'll be launching this feature in a couple of weeks time on our KB Miner as well. So you can watch out and try out your own PDFs and see if you're getting good answers on your tables.
Okay, makes sense. All right. So it's called knowledge base what? KB Miner,
Knowledge,
right?
I think Vivek sir, should I share the website link?
Yes, please. No, I mean, you can actually show it.
Okay, just a moment. Just give me a moment.
You can upload a PDF or a doc and just ask questions of it.
Okay. So this is a knowledge-based miner. Okay. So you can so let me see. Let's take this PDF. This was one of the previous. This is not a PDF actually. This is a PPT. So this was one of the PPTs from the previous webinar that I gave, which was on graph prompting. So this is what our knowledge based miner does. It kind of takes any kind of document, so PDF, PPT, CSV, document, text, and you can upload it, and or a URL, and then now you can ask questions. So what is graph prompting? I have given a very detailed understanding in the PPT. So let's see what is graph prompting, and let's see what our KB Miner bot response.
Yeah, I hope it's working.
No, I think it was working in the morning. Yeah, it's working.
Yeah, it's working. Okay, good.
So basically, if I let me do this. Let me show you.
If you upload multiple documents, will it able to extract that, or a single document is only enabled?
So yeah, we can upload multiple documents. We can add documents within the chat as well. So if you suppose we have we forgot to add a document, and we conducted the embeddings before, so we can add a document here. So you can go back and add more documents. So if you want, I can show you. Let's see if we can add multiple documents. Let's see.
Yes, you can load. Theoretically, you can load n number of documents, but we have not tested the limit. Like we have tried 7-8 documents, it works fine. But if you upload 100, maybe it will slow.
Yeah,
Okay.
that's all. That's also because there's a timeout session between the backend, the UI.
Yeah.
So if you are running it locally, I'm sure you can upload, you can try hundreds of documents, and it should work fine.
So which cloud storage it is using?
AWS. So I think we're not using are we using cloud storage here?
We
Storage?
are storing it in S3.
Yes, sir. We are storing in S3 bucket.
Yeah, okay. So yeah, you can see. So let's ask what are sleep scoring? What is sleep scoring? Let's ask.
The PDFs can be popped open here, not other formats. But
Yeah.
if you, PDFs will open in a pop-up box.
Here. So this is nothing but my bachelor's research papers, actually not written by me, but some syllabus that we had. So I wanted to ask, what is sleep scoring? So based on the sleep scoring paradigm, it correctly detects that sleep scoring is done on EEG, waves, and kind of divided how you name, how do you define the stages. So it has accurately detected those stages here. And this is what happens. So these are the four stages that we see in sleep, and this is the standard approach that we take. So we take 30 seconds scoring 30-second time gap to score every stage. So that is how we do that, and these are the different frequencies that we see. So yeah, I think it does a pretty good job you're using this. So this is one of the areas where we'll be integrating the table mining kind of. So you'll be able to, so maybe you can visualize it in such a way that you have the PDFs here, and you can kind of see individual tables on your right, something like that. So we're working out on that UI aspect as well. So probably in a couple of weeks or soon you'll see that feature getting launched.
So this responses is coming from those PDFs or
Yes.
from its own training data?
No. So we are using GPT-4 on our backend. We are not training the model here. So we've designed an effective, basically a document mining solution. That any kind of document will be the ones processing that document for you, converting it into vectors and storing them for you. Then you can ask queries to that document.
Okay, if you give a question which is out of that PDF, let's say for one example, if you try who is Virat Kohli, which is not in that PDF, see what kind of response come. Now it will come from the GPT-4 training data or
Let's see. So ideally it should not, but let's see. Who's Virat Kohli? I asked.
so
So the standard answer.
from where this response came? From GPT-4 training data?
No, yeah, this one is coming from GPT-4's general knowledge, right? So it is not completely restrictive to the documents you have uploaded. It will still answer general questions, but it will not do so. I mean, it may sometimes say that, well, this information is not given in the documents you uploaded. Periodically, it says that. Periodically, it chooses to answer. So we still have to figure out why GPT-4 sometimes answer out of context questions, sometimes it doesn't. Sometimes it says, well, I cannot answer this because this is not given in the document. So there is still a bit of a play here. See.
Okay. So
I
Vivek,
don't
this
have
is
any.
now the actual question is that how it will decide or technically what it is doing to decide whether this question is available in the PDF or now I have to go out of that PDF to see my own training data. That decision.
No, it
So
is. I mean, it is doing RAG mining, right? It's a RAG miner. So it is doing semantic search of your prompt with the RAG embeddings which we have created in our VV8 vector store on AWS. And if it doesn't find it, it's supposed to give this answer, which is correct. But the why it answered Virat Kohli, so that would be a good question because Virat Kohli is definitely not on those 3 documents she uploaded.
yeah.
So it is sometimes choosing to answer that even though that question is not answered by those PDF documents. So that we still have to figure out why it is able to answer some out of context questions periodically.
So
But
I'll have to
yeah,
specify the prompting. So this is how basically the more we showcase our products, the more feedback we get. The whole point is to improve on what we are doing right now. So we can definitely take back this feedback and take back and go back and modify everything and look into it.
Yeah, probably can improvise the prompt where say that
Yeah,
if
don't answer without
contest is
outside.
not available, don't answer.
yes,
Not
yes,
available.
correct, correct. Simple prompt engineering could do the trick. You're right.
Yeah.
Yeah. No, but overall, it's very good. Excellent.
It's pretty fast also. Plus, it gives you cross functionality. What if I want to upload a PDF, a PPT, and a website together? Yeah, you don't get to do that everywhere else, right?
Oh, website also. Okay, can try that.
Yeah. So if we see add more documents, we have a website here as well. We can
That-
enter website link also.
Yeah, it will scrape just the homepage of that website, not the internal pages. So
Okay.
you can chat with multiple document formats, PDF, PPT, CSV, doc,
Yeah,
PHP, and websites, and it will do accurate semantic search on them.
Yeah. Okay.
We didn't use chain of thought, Bhavani Shankar. We have used RAG, but chain of thought and agent framework is on our product roadmap for sure, because currently our KB Miner doesn't do reasoning and chain of thought. That is on our roadmap. So we are inviting very strong GenAI developers to help us in our product development efforts. So if you have that hands-on skill, you're welcome to. And even our course students who are enrolling in our GenAI course will be added to our product development team.
Dolcy, I have a question.
Yes.
So this, I'm giving a use case. So I'm uploading a PDF which has tables as well as contents. So there is a relationship with the content and the table. So when it is converting, does it do together, or it is just the table alone? It will come up. It will read.
So ideally, the text that is there in the PDF, we are not taking that. We are
Okay.
only using the table and the table text, and we're embedding that alone for now. But yes, if you want, we might have to, we'll have to look into how we can, so basically the thing is, table in itself will give us a lot of information about the text that we see, right? The text that is usually accompanied in the PDFs is nothing but a detailed explanation of why we saw those values, or why we saw those numbers, or why we saw these things or stages or whatever, right? So
No,
table in itself
there
is.
could be multiple. I mean, there could be section where you're comparing two tables, right? Or the section
Yeah.
differs. Right?
Mhm.
Yeah, yeah. Interpretation,
Uh,
sometimes the indentation of what
Mhm.
the table is will be explained in the text.
Mhm.
So it depends on the use case, Sometimes they would do this comparison and explain each columns in the table probably with
Yeah.
the text. So if that is the to have the 100% productivity of this exercise, we need to have some arrangement where we can interpret the columns headings with the text and see some relation.
So I think we can also I think this can also be tackled through one more thing, which is vector embeddings. So if we embed the entire PDF in the same vector store as we are, embedding the tables, and we index them. So table 1, table 2, table 3, table 4, and the entire PDF is like those images are indexed like that. Those PDF pages are, embedded together. Maybe then we might be able to, kind of like maybe come near or try to approach that problem. But definitely, Simi, I'll
you know,
look into it, and we'll
maybe in
work.
a vision text you can give this information also.
Yeah,
You give scraped information.
yeah, kind of. And plus, the thing is, right now we are converting the tables into images, right? So why not caption those images? Image captions also work well. So maybe we can extract the text from in and about the tables, and embed them, and we can caption it using those, something like that. So yeah, the lot of approaches are there, and this is what we wanted basically, to get ideas as to how we can approach different. So different domains will have different tables. Electronics domain and all these manufacturing devices have very different tables. They have these dots and all to show if the parts is present or not, and those kind of things. But clinical trial tables are all about text and numbers, and percentages. So percentages is also we need to tackle that, how much percentage increase. What if we want to ask how much percentage increase was there from one shot to zero shot for from one shot to five shot for llama 1. So we'll have to check all those test cases as well.
Yeah, there's a good one. And also,
Thank you.
but everything I think is a big thing. OCR part, vision part. Even image part. Everything is a big aspect. Which
Absolutely.
can incur some losses. I would suggest that you could go with some domains. Be fine tune on particular type of tables. Maybe
Mhm.
band documents or maybe clinical trials, so that you could work on those kind of documents, because going generic will really cause a lot of issues.
Yeah, a lot of issues.
So that can help. And also layout. Now, I worked on this before, table
Oh,
transformer. And so there are multiple models, like even Cascade tablet now. So if you want to give some information of layout, you should also use something like layout detection or structure detection or layout LM models or something, where you can get some layout understanding of the table, because that is very important in many cases. Right?
layout
And
detect.
even recently, not recently, but since like last 2 years, Microsoft has this UDOP model. If you have heard of it, Unified Vision Text, basically Universal Document Processing Model. So which is a vision model actually, Microsoft's. That can be your add-on, to work on
Okay,
clinics. You can note it if you UDOP model or something.
sure.
That's a good trial to do.
Thank
Great.
you.
That's a good
Thank
Yeah,
one.
thank you so much for the feedback. Adding to that, I was just asking everyone to follow our product survey link. So all the feedbacks will actually be recorded in much structured manner. It will be really helpful for your all feedback.
Yeah, guys. So
Uh,
there is a survey link shared. So basically, now that you've seen how KB Miner works, we would really love if you guys can, fill out that survey and, let us know. So the whole point of these webinars is also to kind of upskill ourselves. So there's a huge things, models are coming out every week, every day, every second. I think from since yesterday, since we have decided to give this webinar, I think 10 models are already released, and they're all claiming better than, some other model, some previous model. So yeah, we might lose track of the progress that we usually see in CS and AI specifically. So these webinars kind of bring multiple thought processes in, perspectives together. I'm not sure if there are plugins for this. I'll have to look into it, Mohammed. And Vaibhav, I guess you have a question.
No, sorry, I just left that open. The reason thing.
It's okay.
So, Dolcy, there were some other questions in chat. If you scroll up in chat,
sure.
I'm not sure if they were answered.
No, it wasn't a question. Actually, I'll code this thing today. So that is what I was telling in the chat.
Okay. So I think Ganesh, we might not be able to. We won't be able to share the code since it's a CellStrat IP. But yeah,
No, it's all right. I'll code it myself. No worries
okay.
about that. Yeah.
Okay. All right.
Dolcy, I can offer
go
a
ahead, sorry.
use case if that's okay with you. We can have a discussion maybe this week.
Yeah,
Where
definitely.
we can see whether this table can be made into a meaningful use case for us. Yeah, thank you.
Oh, sure, definitely, Simi. We'll let me set up a meeting with you Monday or Tuesday. Will that be okay?
Tuesday should be fine. Thank you.
All right. I'll reach out to you.
So, friends, so Dolcy, we are not here talking about our healthcare AI stack, I guess. So we are still working on the.
Yeah, the streaming part is.
Yeah, fine. So folks, we have courses, we have moonshot product development going on. We have our partner or customer projects as well. So if you want to do a collaborative work with us, reach out or enroll in our courses. If you are expert in GenAI already, we are always looking for very good, GenAI developers to help us. You are welcome to present webinars and also join our AI lab community. We have an in-person session coming up on April 20 again in Bangalore, and LLM Jam on a much bigger scale. But we have so many webinars before then. We have another webinar today, in fact. So any final questions for Dolcy? Nice presentation.
May I know
Yes,
where in
Vivek.
Bangalore is this? Sorry, may I know where in Bangalore is this seminar happening?
The Jam in Bangalore is in Belendur Outer Ring Road. There's a WeWork there. So if you know the area, it's near EcoSpace and IT Park areas in Outer Ring Road, Belendur, near Kormangla and HSR layout or Sarjapur Road.
Okay. Could you give us the link after this?
Yes, yes.
Or like,
if you're in Bangalore, we are often found in WeWork, so you're welcome to come and meet us anytime.
Okay. Vivek, is it only in-person meeting or online?
No, the Jam on 20th April will be done in person. We prefer Bangalore folks attend in person, but we'll have a Google Meet link so that remote folks can also engage. Like we did a Jam just last weekend, right? So we did open a Google Meet link for remote folks. But if you're in Bangalore, you will benefit from attending in person for a.
No, I'm not part of Bangalore. Yeah, that's why.
Then you can attend online.
Okay.
We tackled this table thing in the LLM Jam. So we had like a couple of hours to kind of figure out everything. So yeah, I'm sorry it wasn't great, I guess, but we'll be having much more refined workflow soon. So please be on the lookout.
Okay, excellent presentation, Dolcy. Any other questions, folks? Okay, then thank you all for joining. We'll see you in our next webinar. So in fact, the next one starts in about 1 hour.
Okay.